we're good to get started.
All right. Good morning, everyone. My name is Qing Wei. I'm a machine learning specialist from AWS. Today, with my co-speakers, we're going to present understanding security and privacy on Amazon Bedrock featuring Remitly. All right.
Thank you. Yes.
So according to industry surveys, security is still a main concern of many organizations of different sizes. Things like hallucination, data privacy, data protection, shows up year over year in the survey as one of the major concerns. Right? So that's why today in our talk, we are going to focus on generative AI security. We are going to start by talking about the security of Amazon Bedrock. So basically, I want to explain to you what are the components inside Bedrock that is featuring on the security part. Following that, my friend from Remitly are going to talk about their experience of using Bedrock to build secure GenAI applications. At the end, my colleague Raj is going to share with you, based on our observation and experience, what are the patterns to build secure GenAI applications. All right, let's start it. So what is GenAI security? Well, if you think about GenAI security, you can break it down into 3 stages. The first stage is the model itself. That is to say, for the model provider, the model provider need to take care of the data, clean the data, filter the data, to make sure the model that is trained is secure. And after that, the second stage is the model access. So that means who has authenticated, authorized to have the data access, right? And lastly, you need to look at the totality of the GenAI application security. So that means, before your data reach to the GenAI model, right? What is the security of the data, before it reaches to the model? And then after the model produces output, right? We need to make sure that, maybe the output need to comply with our responsible AI policy in your organization. So if you put those 3 parts together, that's the totality of the GenAI security. So now I want to start by talking about the security of Amazon Bedrock. All right, so just a quick introduction about what Bedrock is. Bedrock is a fully managed GenAI service that makes it easy for our customers to build and scale GenAI applications. So customers can get access to GenAI foundation models serverlessly. So that means you don't need to train your own model. You don't need to worry about deployment, the infrastructure. You can access the model serverlessly. One of our commitments is to provide our customers with the best and latest foundation models. We want to give our customer choices. Here on the screen, you see the list of the foundation models from the different model providers. This includes the powerful models from leading providers like Anthropic, Meta, Amazon, and more. I'm sure that many of you have experimented with the foundation models inside Bedrock. Okay, so we know what Bedrock is. So what does Bedrock do to ensure its security? I want to start with the Bedrock security on the data privacy and protection part. So first of all, this is absolutely fundamental. I might repeat this several times during today's session. We do not store your inference and training data. Right? So if we do not store it, there's no way it can be leaked. Right? It cannot be shared or seen by the model provider. It cannot be used by Amazon for any purposes. Right? The only data we store are the operational metrics, such as usage data for billing purposes, or some of the metadata, so that when you log into your Bedrock console, you will be able to see, these are the list of customization jobs I have inside Bedrock. All right? The next thing I want to point out is all the prompts, all your data, right, is isolated per customer basis. And it is also remain in the same region that you send the API request to. So if you send your Bedrock invoke model request to Frankfurt region, the request will stay in the same region. As I mentioned earlier, that we want to give customer choices of foundation models. But it's actually up to our customer to enable the model in that account. So you decide which model you want to enable for which of your users inside your account. We also make sure that all communication to, from, within the Bedrock services are encrypted. It's always encrypted in transit. Another thing is, if you fine-tune model, right? We need to have a copy of your model to serve it to you inside Bedrock. But you can encrypt your model with your own KM's keys. So that means only the customer has access to the model. Also want to point out that Amazon Bedrock also achieved a number of compliance programs listed below. All right, so now we talk about data protection, data privacy. Let's move on to connectivity. So let's look at the setup first. On the right hand of the screen, this is Amazon Bedrock service account. So here is where the Amazon Bedrock service component sits, whereas the API endpoint sits. In the same region, we will see that on the left-hand side, we have our client's account. And inside the client accounts, we have our customer's VPC. So when customer make an API call to reach to Bedrock service, right, there are two ways. One is through the public addressing space. The other is through the private addressing space. I'm going to explain the details and the difference between the two. The one you see on the screen, the yellow line here, represents the public addressing space. So inside your VPC, you made a request to Amazon Bedrock. The traffic has to go through internet gateway first, and then from there, through public address space, it reaches the API endpoint. Even though we keep mentioning that it is through public address space, but if you look at the traffic, right, it never leaves the Amazon regional network. So that means your traffic is not exposed to the public internet. If you are starting making API calls to Bedrock service through your corporate network, well, then you have to route the traffic through the public internet and then route to the Bedrock services. So we understand that for customers who has maybe resources inside your private VPC, or maybe you have a policy to say that public internet space is not allowed within your account. In that scenario, this doesn't work, right? So that's why Amazon Bedrock also offers private connectivity options. So here it is. First, we need to create a VPC endpoint, right? So basically, this establishes a private connection between your VPC with the Amazon Bedrock service. So from here, you can see when you make an API call, when you make a request to the Bedrock service, the traffic is privately connected to the API endpoint. So there's no public address space at all. So this ensures the private connectivity. All right. So now let's talk about access control, right? So the IAM administrators controls who are authorized, who are authenticated to have Bedrock resource accesses. So on the screen, you see two example policies. Right? One specifically defines the permission of a model. The other allows a permission of a model. This is very handy because you can fine control the model access through policies like this. What's more, we recently launched a feature called the Application Inference Profile. So think about Application Inference Profile as a resource that you can send your model invocation request to. So this is very nice because you can attach tag to it. Well, you cannot attach tags to the model ID itself, but you can attach the tag to Application Inference Profile. So this becomes very helpful because you can add in your IAM policy a condition element so that you can further fine control who has access to which model. In my experience, I see my customers build multiple application inference file, maybe for the same model ID for different applications. So this gives them very granular level control of the access to the models. All right. So now let's talk about observability and auditability. All right. So first, I want to point out that you can monitor Bedrock using Amazon CloudWatch. So Amazon CloudWatch, it collects raw data and processes it and presents it in very readable real-time metrics. So you can see on the screen metrics like the number of invocations, the latency, the errors, etc., are all presented in the CloudWatch. Furthermore, you also have the option to turn on what we call model invocation logging. By default, this is turned off. So what this means is, all the requests, the input requests, the output, the metadata associated with the request will be saved into your own account. Although it's saved, but I want to point out, it is in your account. You are the only one who has access to it. Amazon Bedrock is also integrated with CloudTrail. So CloudTrail provides a record of actions. So you can see by user, role, right, who is doing what inside your Amazon Bedrock account. So basically, I want to point out here is, with CloudWatch Trail, with CloudTrail and CloudWatch, you have full auditability and observability inside your account. So lastly, I want to point out that we talk about responsible AI a lot. Right? We have Amazon Bedrock Guardrail. I'm not going to go to the details of every component of the guardrail because my colleague Raj is going to go there. But on high level, you can think about guardrail as safeguards that ensures your responsible AI policies are guaranteed. Right? So when a user sends a request, the request is sent to the guardrail, to the safeguards first. Right? If nothing is detected, no violation is detected, the model will receive the request and get the inference. Well, if there's violation detected by guardrail, right, an approved message, default message will be sent back to the user. And of course, you customize and control what kind of message you want to send back to your user. This applies similarly to the output. When the inference model generates output, right, it also goes through the safeguards inside guardrail to make sure that all the response or the AI policies are guaranteed. All right. With that, I think at this moment, you probably get a good idea about the security features of Bedrock. So now I want to hand over to my friends from Remitly. Thank you.
Thanks, Kyunghae. Hi, everyone. My name is Ankur. I'm the VP Product Management for Remitly, and I'm very excited to talk about our implementation of Bedrock, how we've used it to transfer experience for our customers. Talking a little bit about Remitly, it is a digitally native app that supports customers sending billions of dollars across the globe, each year fast and reliably. Our vision, as you see, is to transform lives by providing financial services that transcend borders. Most of our customers use us to be able to send the money across border, across multiple use cases. Cross-border remittances serves a very, very critical lifeline for a lot of people and customers. And let's take a deeper look from two perspectives. There is a strategic lens in which, according to World Bank, remittance volume to low and middle countries was over $656 billion, far exceeding the foreign direct investment or any amount of development grants at that scale. Now, let's take it at a customer lens. For our remittance customers, in the year 2022, we actually did a study around 2,500 customers, asking them how this money is being used for. 52% customers said that 50% of this amount is actually used for household expenses. So now you can see why being transparent, on time, and being very, very reliable is important to our customer needs. Our superior product that's been built over a scale of 13 years has led to trust customers have with us, which is reflected in the 7.3 million quarterly active users as of last quarter, 14.5 billion quarterly volume that we sent across, and our global footprint across about 170 countries. And as we truly say, we are just getting started. Now, I'm going to talk a little bit about how we are transforming support experiences with generative AI. We are a digital-first player, which means that we actually look at solving customers' problems using technology. And within the fintech space, there's a lot of innovation explosion that's happening. So we are always looking at new technology and how that can enable us to be able to solve customer problems. And that's the implementation that I'm going to talk about and how we applied this technology. First things first, let's talk about what typically happens. So delays, as I've referenced, erodes trust in our business for our customers. And about 95% of our customers actually have their transaction delivered without the need of customer support contact. Many of these transactions were actually delivered faster than even customer expected. But in about 5% transactions, we're not able to deliver. We need the customer to be able to give us some information, or these customers contact us in terms of knowing what is the pace of delivery and why it's not there. In these scenarios, support experiences are critical to customers' peace of mind and having trust in our services. So as delay happens, as the time goes, the customer trust goes down. That's a very direct correlation for us. So ensuring customer support experience as we grow is very, very important. Just to talk about a few numbers, we've been growing at about 30% clip for last many years. Just in the last quarter, as you see on the screen, we had 35% year-on-year growth in our total active customer growth and 42% in the send volume. So now you can imagine our support volume is actually growing at similar pace. Along with that, the other challenge is we serve 18 languages. So in 18 languages, it becomes really important for us to be able to drive the support. So being able to do support through manual agents becomes harder and harder to scale. So technology has become a very important part for us to be able to drive that. We've taken a very, very aggressive goal of reducing our support volume by 4x over a period of time, and we're using technology to be able to solve that. Key considerations for us to solve as far as support is concerned: fast resolution time. We've seen a lot of times that fast resolution is directly proportional to the customer satisfaction. We have to adapt to multiple use cases, and they come in many shapes and forms. First, there is the structured transaction data we have for the customer and the unstructured text in chat. So that's a variation that we have to deal with. Real-time online chat experiences are required to infer intent very, very quickly, sometimes in less than 100 milliseconds. Then the third, the customer itself, the query can be very different for them. They can sometimes ask, I need to change something on my account, and I want to understand what my transfer status is. So that is a lot of adaptability that we have to go across. Support requires multiple communications. We have to be present where our customers are. If they want us to have an async conversation on email, we have to be there. If they want to have a phone and chat and rapid conversation, we have to be there. So we have to adapt to that. And compliance, personal and financial data needs to be secured. So it's very, very essential. We are a financial services company. So with generative AI, we actually saw a new opportunity in a couple of places. There is superior performance in terms of intent classification, and also we can create a lot of better customer experience through a generated response for our customers. There's ease of customization in terms of rapid deployment of new use cases using prompt engineering and versus doing the traditional encoder and decoder model. That becomes very heavy lift, so it's a lot faster. And then within the generative AI, there are capabilities like RAGs and guardrails that is making hallucinations lesser and allowing us to leverage large language models, which hadn't been the case. Finally, to match scale to the size of the problem, use cases can be very, very different. So we are able to scale workload very, very efficiently. That's another advantage that we get out of this. Key challenges, I'll break the challenge in two forms. The first one, the operational challenge, which is we need to discover the right document that needs to allow us for references to be able to enable customer responses. Responses need to be very, very snappy, sometimes in less than 6 seconds for the customer to be able to kind of achieve that. And response accuracy is fairly important for the customers to be able to trust the technology and also trust us. So that is very, very important. The security part of the challenge, which probably is obvious to you, but we are a regulated financial services company. So data privacy, access control, and network security is exceedingly important. Support transcripts that come to us also contain personal data, so they need to be handled in a very, very secure way. Data is very critical to personalize the experience, but it is also important to securely store and handle it. So that becomes very, very critical. Let's talk a little bit about how we broadly thought about the solution design now. So the customer actually enters their search query into a traditional bot, and we have transaction data of the customer, and we combine these two things to do a hybrid search using a traditional search, a combination of traditional and neural network search. Then it goes to the content retrieval section, where the search is used to retrieve the data from the Remitly context that is stored in self-help guides, content snippets. In retrieval, we are trying to search for what is the exact reference document that we can use. Then we got to the stage of what we call response generation. We are looking for validation accuracy, which is we search our subsystems for correct references, looking for accuracy in content retrieval, and also accuracy in content generation. Then we move to the next stage, which is response validation, which has got like 3 steps to it. First is, did the response cite a reference document? Second, was the cited document in the reference material that we had given it initially? Did that come? And then coherency, which is the response, the question, and the reference document coherent to the context of what the customer is what we are trying to answer? Let's look at the architecture now very quickly. So we see here we have got the traditional chatbot in which the customer kind of enters their request. Within the chat interface, we have the remediation system, which is basically our intent classifier system, as well as we have got our Q&A workflows that are within this. The pre-existing systems within this framework also has all of our content and any customer information that we have. So the flow will be something like this. Customer asks a question in text, and we'll use the data that we have to get an intent classification to be able to determine, does it fall into an FAQ-style intent? If it is an FAQ-style intent, the Q&A workflow will get invoked. Once the Q&A workflow is invoked, we will actually do an open search in Amazon. And here we are doing a search embedding using the Bedrock embedding API, where we embed customer preferences, any customer information, the customer question, and then we use a hybrid search to retrieve the reference material from this. All the reference material and the customer question is then handed to the Bedrock Converse API, and that generates a response using the Claude Haiku model. We will pass that to our guardrail system. If it meets our guardrail, great. If it doesn't, we take a second pass using a more stronger model, which is the Claude Sonnet, again going through the overall response generation through the guardrail. So why Amazon Bedrock? Let's talk a little bit about that. Bedrock provides a very good, clean separation between 2 distinct responsibilities. My colleague just talked about one is the model provider, who provide the curate data, train foundational models, and release them as a product broadly for customers to use. And then there are model hosts, which provide reliable and cost-effective ways of accessing that models at scale. This separation is baked in the core design principle that encourages data privacy by ensuring an intentional air gap maintained between the model training process and the model used for inference data. It also helps us prevent a vendor lock, right? Especially in the days when there is no clear market leader as far as models are concerned. And then the native AWS support for existing IaaS access controls has always been very, very helpful. Finally, in partnership with the AWS team, the guardrail system wasn't there. So we actually built our internal guardrail system within Remitly so that we can continue to make progress in this while the Gen AI tech overall matures over time. I'll quickly walk you through the overall demo right now. So you see this is our traditional chat interface. The customer kind of goes through, will click through chat, and our chatbot will very quickly show how can we help customers. This is a generated response, as you see. The customer is going to type in a request to ask about a particular payment type, how they can pay. Ban contact is a very famous payment type within Belgium, and it is very, very widely used there. So you see, at this point, what's happening is that all the information has been actually taken in, and now the chatbot is going to respond. So within the right diagram, it's the intent classifier that's working and determining it's a QA intent. Going to our next, here is where the response is going to come from our LLM model. Here's the generated response that comes through, which talks about this is the entire generated response, which talks about how they can use, but it also quotes a reference document where the customers can go and get into more details. So within that, if you see now, actually it went through the retrieval and the generation process, went through the guardrail system, and generated the response for the customer. Let's talk about our results. We've seen very strong results. It took us about 2 months to set up this entire system, so very easy effort to be able to drive that. As of now, we've seen an adoption of 25%. What I mean by that is 1 in 4 chats are being handled by our chatbot as we speak to our customers. We have had great satisfaction. A lot of resolution has happened. But one of the biggest things, my favorite part, is that customers always have the option to actually go to a human. But when they're interacting with the chatbot, only 3% actually go forward, which is a huge win for the technology itself. So key takeaways, first one, security is a starting point for implementation. So it is a given versus it being an afterthought. It is very tempting to start with state-of-the-art models, probably very good to be able to do from a POC perspective, but the cost and latency concerns can become limiting factors fairly quickly. Engage with the reference data in customer query. That's very, very important. Be very cautious about language-specific nuances because models can perform very, very differently. And then finally, LLMs do well in validating a solution than solving a task itself. We have a broader vision of how we are going to use and scale generative AI further. First is expanding coverage of implementation with new intent-based remediation workflows, addressing more customer issues directly within the chat experience. We also want to leverage the language understanding capabilities to better detect when intent classification gets off the rails so that we are able to guide it and come back as we speak to the customer. We're also expanding generative AI beyond support itself. One of the examples that we've been talking about is how do we do marketing content generation. That's an example where we are implementing out of support. And then obviously expand the data source and build with the Amazon Bedrock guardrail versus us hosting it ourselves. With that, the last thing I'll say is I'll talk about a quote from our CISO, who's very, very thankful, Darren Challey, who's talked about how thankful we are with our partnership with AWS and the products that we are able to do to be able to build necessary control to keep our customer data safe. It's very important for us to be able to continue to innovate for our customers. Anything we can do to be able to fast track the ability for customers to send money fast is something that we're going to strive for. With that, I'll call Raj, who'll come and take it from here.
Thanks a lot, Ankur, and appreciate everybody making their time. So what we're going to do now is kind of look through the whole cycle of generative AI. We talked about it a bit, but let's rewind, right? Going back to step one, when we think about building a secure foundation model. When you start looking at building kind of these large language models or generative AI models, it's a two-step process. You got to make sure you're curating the right data, and you're going through a process of pre-training. The next step, it's probably the most important, is post-training alignment. What this means is that the model providers are actually tuning their models for safety. How do we actually adjust the behavior of the LLM to give more safe, secure, or aligned responses? And this is really where Bedrock wants to give you choice. Hey, based on the actual provider, based on their terms, based on their performance, we want to make that really easy for you. My colleague Chinwei talked a lot about how security model access works, and we want to make that really simple in Bedrock. This is an AWS service. You authenticate with IAM, you have those same network controls, those data controls that you're used to. And because we host the model artifacts from the providers in our service account, the access becomes a lot simpler, so we can make sure that none of your data is leaked. The last step, and this is probably the thing we've seen most of our customers really ask us about in security, is what do we actually use the model for? Hey, I'm putting it as an application. How do I implement it to make sure that it's not hallucinating something? Or the data I'm sending it is secure? Or hey, I'm trying to implement a different type of pattern. And when you start thinking about building with generative AI, it introduces a few really considerations. There's an extensive list, but really the most common ones I hear are, hey, what do I make sure this thing doesn't hallucinate something it shouldn't? How do I make sure I have visibility at every step of the way? How do I bring my traditional auth-in or auth-c controls into the mix? How do I make sure that the application stays relevant? It's grounded in a specific type of data. People can't manipulate it or send it harmful attacks, or things like prompt injections or prompt leaks. I mean, these are really the controls I'd say most of our development or developer community has to think about when they build with generative AI. Most folks aren't building foundation models from scratch, nor are they hosting it. It's really, as a consumer, how do I bring security into it? So with that, I want to introduce two types of controls that are really relevant when you build generative AI applications. The first one is what we call a deterministic control. Really think of a deterministic control as something that can be reproduced. If I do it the same way, it's explainable, it's reproducible. And it's designed to make sure that the data getting into the foundation model, or before we even authorize or authenticate a user using our application, we're trusted. We have access to the right data, we have access to the right capabilities, And the idea here is before the data gets to the model for inference, we've locked it down. This is built off of things like IAM, KMS, your auth-in, auth-z controls, really things that are controlling access before it gets to the LLM. This can also be things like regex checks in the Amazon guardrails as well. The next one, it's a little more confusing. It's really for folks that are getting started, is what we call a probabilistic control. A probabilistic control is much more designed for the language type tasks. This is where we're preventing harmful system input or output. We're making sure that this thing's case relevant, and it's really designed to help solve broader problems. Chances are you're not going to be able to write if statements or logical statements for every single piece in the English language, but when you set up themes or machine learning type checks, you can be very broad with what you protect yourself with. However, it's good to know that these are probabilistic, and there is a level of risk we have to accept. So throughout the session now, we're really going to talk about how, when we think about big patterns in architecture for generative AI, how do we combine these two controls to actually get the end-to-end story? We've noticed that the three most common patterns we see our customers implementing really come down to how they combine, right? The first one is prompt engineering. It's really just what are we sending the model, and how do we make sure it has the right information to solve its task? Ankur mentioned it before, but really your prompt is what dictates how the LLM will respond. By default, LLMs introduce this new concept where there's not really a separation between data and functionality, right? They come with a pre-trained corpus of information, so we really have to steer the way that the response generation comes in. And prompt engineering helps you do that in a very probabilistic way. The next one is retrieval augment generation, where we're taking a granular data source that we have, and we're creating a vector embedding of it, and then based on what the user is asking, we're injecting that into the context so we can ask and generate the right answer. We want to make this as deterministic as possible before it gets to the LLM. The LLM is a probabilistic type model, so how do we make sure that the data that's coming into the LLM is good? It's vetted. And lastly, how do we make sure we get the right citations? And a really emerging pattern that we're seeing a lot of our customers use is this concept called tool use, combining that with agentic behavior, where we're now having it, instead of just touch static systems or static repositories, actually hitting real-time information. It's hitting our APIs. Introduces a new kind of attack vector in the sense that, or is it authenticated to go use my API? What if the right action isn't valid? How do we make sure that it's not doing something it shouldn't? And lastly, when we think of autonomous agents, hey, this is taking really action on its own. So how do I make sure that it's secure? And we're going to walk through that today. We're going to do that really in a four-step process, right? I want to think about it as defense in layers. There's combinations of probabilistic controls, and there's combination of deterministic controls. So let's think through it in an actual application scenario. And the first one we're going to start with is building the correct prompts. So let's work on the notion that we've gotten access to an Amazon Bedrock model. We have the correct IAM and role permissions. We're actually going to go invoke that model now. When you start building prompts themselves, there's two components to think about. There's the system prompt, and this is probably the thing you're going to adjust the most. These are persistent instructions that you're sending the LLM. These are things that define the model's behavior and the capabilities you're scoping it down to. We talked about this earlier, but LLMs don't really have that true separation of data and functionality. It really comes with what it comes with. So this really helps us scope that down. Your user prompt is really the question you want your LLM to be able to answer. This is what your end users may ask you. So you want to let your user prompt inform your system prompt. You want to make sure it's designed for edge cases. It's designed for things where, hey, will it fulfill the scope of my problem? There's a lot of best practices when you think about actually building a prompt, right? This is a long list, but hey, what does it actually matter when you start thinking about the world of security? So we ran a quick test where we took the NIST adversarial attack, and we generated about 50 use cases where we then prompted a model to do a classification task for us. What we noticed is when we gave it an unoptimized prompt, so a very generic question, it passed about 24 of the 50 attacks. And this is a very high-performing model where it was able to give us something it shouldn't have about pretty low pass rate. But when we incorporated these changes, that went straight to 100%. So when we start thinking about things like prompt attacks or prompt injections, these become really, really important because, yeah, the providers are pre-training and aligning their models to those, but our usage really has to align to how we give those models instructions. To visualize that example here, this is what the unoptimized prompt looks like. It's a very simple prompt. It's, hey, your job is to classify the interaction as these three things, don't do anything else, and don't respond outside these 3 points. Very generic prompt that we give. What we did was we took the model-specific best practices, so this is with the Claude 3.5 model, and we did Claude best practices to actually generate the prompt itself. You'll see it's substantially bigger, but when you read it, it's really like a step-by-step guide of how you want the model to think about the problem space. You'll see I'm using XML tags. That's a very Anthropic-specific implementation, where we're actually writing out step-by-step how we want the model to approach the problem. And you'll see we're introducing this concept called chain of thought, where we're having the model think through the actual problem space, think through its input, and think through how we want it to respond. When you think about security, this really improves accuracy, right? Before the model responds or generates something, we're having it kind of go through its own thinking process to see if it's actually secure. And what we noticed in this exercise was as it went through this, it kind of determined that, hey, this person's trying to attack me, I'm not going to respond. If you are, this is extensive. We did launch a service recently called Amazon Bedrock Prompt Management. This will help in kind of adjusting these to those model specific activities. Great. So we built our prompt. We have a good prompt ready to go. But this is a probabilistic control. And like we mentioned, these are model provider specific kind of exercises. And it's really hard to do that across every single model provider. So what if I need controls that are consistent? And this is where last year we launched Amazon Bedrock Guardrails. Guardrails is a model agnostic safeguard. And the idea here, as we mentioned, is we're blocking both the input along with the model-generated output. And we're checking them against 6 different filters. Some of them are probabilistic, some of them are deterministic, and some of them are a combination of both. And we'll touch on that shortly. But in some internal testing, we noticed that by adding guardrails into the workflow, we were able to block about 85% more harmful content than just using the LLM as its whole. We also saw about 75% reduction in hallucinated outputs for RAG. And again, the combination together works really well. As you start building with LLMs, really think of it as defense in layers. I'll quickly walk through the different components of guardrails, and the first one is content filters. The idea behind content filters are we at AWS have defined responsible AI pillars, and we've created a set of machine learning models really in the back to help see if this input or the generated output is harmful. So think of things like hate or prompt attacks or prompt leakage. The second one is a combination of deterministic and probabilistic filters. And these are sensitive information. So if you're using something like a regex check or actually defining a regex pattern, that's very deterministic. It'll always work every time. Where we get a probabilistic control is really a machine learning model we built for PII. So think social security number, name, address. You can't define a regex pattern for all those. So these models are really doing that for you. Next one is denied topics. Really, it's something you don't want your model to talk about. Hey, I'm building an application that shouldn't give me fiduciary advice. It's now going to detect if there is any sort of intent for fiduciary advice, and we'll block that. And if we see that in the response as well, we'll also block it. Next one is word filters. Really think of this as a set of words or phrases you just don't want it to talk about. Think competitor names or phrases that it shouldn't do. The next two are fairly new. Contextual grounding is a combination filter that will see if the response generated by the foundation model is relevant to the source. So this is really popular in RAG use cases where we have the source documents that we're pulling from the embeddings. And we're checking and doing a relevance check on, how relevant is it to the source document, and how grounded is the answer in those source documents. And a lot of you may have seen the launch that we did yesterday with automated reasoning. It's the one that I'm probably most excited about because it brings deterministic actions into the world of large language models. And we're going to talk about that in a lot more detail. The way to really think about automated reasoning is, for a lot of those folks who come from computer science or engineering backgrounds, think of these as deterministic or discrete mathematical checks, where if we have a source document, what we're going to do is we're going to send it to our automated reasoning service with a certain intent. So, hey, use this document to generate the procedures for our leave. What automated reasoning will do is it'll create an automated reasoning policy. So we'll define a set of variables, and we'll define a set of rules based on those variables. Think of these as logical statements. If greater than, equal to, just a really logical representation. It's then stored as a policy, and this component is probabilistic. So it's important to know you can edit these if they don't meet exactly your requirements. Next, we'll associate it with a guardrail. So anytime now, when a Q&A is sent to the actual model to validate, what we'll do is we'll do that translation again. We'll turn the user's question answer into a representation of a logical statement. We'll then now do a deterministic check against those rules and variables you'd created with the new representation of the Q&A check. From here, that really introduces two big concepts. If it passes, what we'll do is we'll tell you it passed, we'll tell you the variables that were used to make that check pass, and all the different assumptions we made for it to be valid. In the scenario that it doesn't meet a rule, what we'll do is actually tell you the exact rule, the values for why it didn't work. And when we send it back to you, we'll actually give you suggestions on how you could change your response to make it valid. So this really introduces a new paradigm when we think about security and hallucination control, because we now have explainable kind of decision-making within generative AI. So when you start thinking about more procedural documentation, this can really help with that explainable component. But just to note, this is a combination of both probabilistic and deterministic controls. The check is deterministic, the actual generation piece is probabilistic. Great. So we talked about how we can now add in both the right prompt and the right guardrail. Let's actually get into using our data through some of these more popular patterns. The first one I want to talk about is probably the one that everybody uses today, and that's RAG. And I want to talk about how we do it with Bedrock knowledge bases. And the first step is actually ingesting data and creating vector representations. So let's start with the actual requests made to the control plane on Bedrock. We have to make sure we have the appropriate role and the permissions to actually invoke the API. Do we have it in the right region? Do we have it with the right service role? From here, we'll actually hit the Bedrock knowledge base API. This is a runtime. It's really important to understand that this is not using an LLM directly. We're hitting in runtime with the service itself. From here, we make sure that the service has the right role to now go invoke an action. What this will do is it'll reach out to the document repository you want to store from. So if you're using Amazon S3, it has to make sure it has the right S3 permissions to access. If it's hitting one of our external sources, also make sure you have the right authentication, you have the right permission to actually load that information into knowledge base. Once that's done, what we'll do is we'll actually send that information to a model on Amazon Bedrock. Again, it's important, knowledge base has to have those roles and permissions to actually go call that embeddings model on Amazon Bedrock. We'll then take those vector representations of your documents, and we'll write them to a supported vector database. Again, if this is a vector database on Amazon Bedrock, you can define this entirely with IAM. If it's external, you have to make sure you have the right authentication mechanisms. Something to note here, this is not an LLM doing any of this stuff. This is in a runtime. So when it comes to the actual usage of something like this is where we want to think about where do we authorize, where do we authenticate before the call actually gets sent for something like a RAG call. So let's say we have a user that's using an application. Our application has the right roles and permissions to call it the knowledge base API, but how do we make sure our user only sees the data they're supposed to see? They're not allowed to see someone else's information. Step one, before data even gets sent to the knowledge base API, let's authenticate and authorize our user. This could be with your traditional auth and auth controls, but now we have an identity of who the user is. So we can actually filter information before it gets to them, so we don't run into the confused deputy problem. From here, there's a lot of different things you can do with RAG that are really unique. The first one is this concept called metadata. So within knowledge base, you can associate certain metadata with documents that you ingest for RAG. This could be the group that's allowed to see it. This could be the year. This could realistically be anything. And the reason this becomes really important is it helps you pre-filter before your RAG call happens. And we'll talk about that really shortly. From here, that then gets sent to the knowledge base API. And from here, we'll call the embeddings model that you used to create all those documents to now embed the query. We're now going to do what we call metadata filtering. So we're going to filter based on the query that you sent. So this is a way of making sure that the person that we've now authenticated, authorized, we're now filtering documents from our vector database before they even get to the end user or get to the LLM for generation. So we've scoped it down a lot further. It's not a true authentication or authorization mechanism, but it is a way of making sure that this user is filtered to what data they're allowed to see. So when you think of multi-tenant type solutions, this can be really powerful. We pull the data from the actual vector database. And now we're going to send that to the large language model. Again, knowledge base has to have the right permissions to do this. Once it gets done, we'll send the request back to the end user. So as you kind of look through this flow, you'll see that we're authenticating and actually doing the permission at every single step. And there's ways that you can bring in controls like prompt engineering to make sure that the prompts you're using for generation are specific. Or, hey, I want to include guardrails because I want to make sure that it's grounded in its context. But we're not removing any of our deterministic controls. We're still making sure that it has the right IAM policies. We're still making sure that it has the right IAM rules. So this is really how these two work together in something like a RAG scenario. What I want to talk about now is probably the thing that everybody's excited about from reInvent, and this is how you would think about it with agentic behavior. Agents, you bring a really unique perspective where they can actually take actions on their own. You can implement them into a more dynamic kind of workflow. But how do you make sure that process is secure? This is where we bring in those combination controls again. So let's think about the scenario where we have an application. We give it the right role, we give it the right policy. From here, we authorize our user, we get the information about our user. Something that I like to call out is there's a component in Bedrock agents called the session attribute. A session attribute sits outside of the LLM, but this helps us with the runtime itself to pass it to an API. It could be a thing like a session token, it can be a thing like an auth mechanism, but really it's going to be the thing that helps us authenticate with our user as a deterministic type control. From here, we'll make sure we have the right role, and we'll call our agent's API. This is where the combination between going back and forth with the large language model will happen. Depending on the user's intent and what they're trying to do, the LLM will go through this process of chain of thought. This is entirely driven by the instructions or the prompt that you gave your agent. It'll then generate its next step action. We'll send it back, and then we'll go, hey, do I need to make a call to knowledge base to pull static information? Or do I need to go make a call to something like an action group or a set of tools? And this is where that session that we talked about, those session characteristics, those authentication controls, will then be passed to the actual APIs themselves. So when you think about security in this flow, the LLM isn't the one making the calls. The LLM is simply just saying, this person is trying to do this, I need to use this tool. I need to call this knowledge base. And what we're using is a very deterministic control with something like a runtime on agents. Agents also has this really cool feature where if you want to have users confirm their actions before this action is even taken, you can incorporate that. And the way we're doing this is when you pass an API spec, you can add this on, and this will have the user confirm their actions. So without even having this take autonomous action, you can have a human-in-the-loop flow. And at the end of it, it'll work with and send the response back to the user. So really, just as you start thinking about these two big patterns, these are how the two work together. Still under the guise of a very deterministic control combined with a more probabilistic type approach. So to really think about it as an end-to-end architecture, how do we make sure we align our application to our desired outcomes? Let's start with what we talked about, really bringing it all together. We can enable things like IAM. We can enable things like AWS, CloudTrail to make sure we're logging those API actions. Lastly, if we want all of our interactions, all the prompts, all the responses, we can log that in Amazon CloudWatch. So let's authenticate and authorize. We'll then send a query with the respective metadata along with our session attributes. From here, we'll make our first call to Amazon Bedrock guardrails. This is incorporated with things like agents and knowledge base out of the gate. So we'll authenticate the user's query to make sure that it aligns to what we want. If it does, we'll send it off to our agent. And we'll make sure that our agent instructions is prompt engineered with best practices in mind. From here, we give our agent the right role and the right permissions to take the actions it needs to take. It'll then determine, hey, I need to call a knowledge base. All this information will then be persisted. You'll have the metadata pre-filtering. You'll have those corresponding session attributes. But it's really a no-trust process. Does the agent have access to actually call the knowledge base? Does it have the right permissions? From here, great, I need to go call a more dynamic action. That same check is still done. Do I have the right role? Do I have the right permissions? What's the process I need to do to take in this information? At every step of the way, this check is done. And then, when you have an actual response that you like, it's validated again by a guardrail. We double check that process. And lastly, when that's done, that's when the user actually gets their response. So what I would say as you guys start to build some of these patterns and these architectures is it's really important to bring both of these controls in together. There's a probabilistic element in generative AI, but when you start thinking about building applications and controlling access and data, that should be deterministic as much as humanly possible. These probabilistic controls come in, and we want to make it a much more broader problem. So let's put it all together, right? Going back to our original list. Hey, I want to implement something like protecting sensitive data, or PII. Using deterministic controls to actually vet the data, filter the data before it gets to the LLM, and then you'd want to use it in conjunction with something like a guardrails sensitive information filter to block out PII. The next one is how do we make sure that all these interactions are logged? With Bedrock, we do this out of the gate, so just make sure model invocation logging is set up. Next one is how do we maintain consistent network and security controls? Really think about these as deterministic checks. These are things like IAM, KMS, your network controls. And then when you start thinking about auth and auth controls in agentic type applications, this is where session attributes in Bedrock can be very powerful. How do we make sure that things are relevant? And how are we protecting yourself against harmful attacks? This is where things like probabilistic controls come into play. You want to make sure you have the right prompt engineered instructions to your application, make sure your system prompt is good, and then think about defense and layers with things like safeguards and guardrails. Last but not least, how do we make sure that we're authenticating and authorizing requests? Don't have your LLM do that. Have your traditional mechanisms you've already built out and structured to have you do this. It can be challenging, but just remember, there's two types of controls to think about, and they each play their own interesting role. As next steps, we have some great resources to help you guys get started. Highly recommend you check them out. It'll help really make this stuff real. Give folks a few seconds to check it out. And good to go. Sweet. And yeah, we appreciate everybody coming to the session today. Really hope everybody can fill out the session survey, and thank you all so much.